Hello folks, welcome back to the Cookboot, a video series where we are building a website dedicated to managing cooking recipes and focusing on the backend setup of a website. Again, if you don't know how to code at all, you would benefit from learning some basics, as I'm not going to go into those. Otherwise, well, today let's talk about the project setup. Last time we talked about the basic setup of how does the user to the machine communication works, and then we talked about kind of how a web server sits between a request and some logic that we want to execute, and then how we're going to use some technologies like Falcon, a web framework, to actually help and connect the web server. We're going to use uvicorn as a web server, and then Falcon as a connection, as a web, or in this case, API framework to connect our web server to some custom logic. Today, let's talk about the project structure, project setup and structure. And for this, I'll actually, well, let's use the terminal. And I'm currently in the root folder of my project. And this root folder looks like this. So there is a README file, which is for the, let's make it a bit bigger. And let's clear and repeat. So there is a README file, which is for the GitHub to have a nice README. Then there is a pyproject.toml, which holds, this is a file which holds a lot of configuration for our project, which we're going to look into in a second. Then there is the source directory. In this folder, all the files which somehow are connected to our code reside. Then there is test folder. Well, this obviously will hold all the tests for our project. And then there are two files, uvicorn log.config and log.config full. These are connected to the log configuration of the uvicorn, our web server, and the log.config is the one which I'm using, and the log.config full is actually an example of a kind of more extended version of the log.config with some additional stuff which I don't need right now, but might want to use a bit later. And hence, that's why I'm keeping it here. Now, the first important thing is this distinction between the source and the tests. There are actually two strategies how you can treat your tests. One is to keep your test files as close as possible to your source code. So whenever you have a file app.py, you would have test app.py there. And the second one is to keep tests separate. I definitely prefer the second format because this allows us to decouple two, and we can ship, for example, if I want to deploy my source, I don't need the tests there, like not necessarily I need tests. And I think this is a way more cleaner setup. And again, when I'm going to read some code and maybe, I will be wandering through a code structure, I don't want to see those tests at that point in time. They're kind of a separate entity. So that's the distinction here. This distinction, although, will bring us some problems in Python because now tests will need to be able to discover files in the source and vice versa. And overall, kind of importing modules in Python, unfortunately, is not as straightforward as I would like it to be. And that's where pyproject.toml is really helping us. So let's look into what's in this file with a cat. This is a project in the toml standard, which is something kind of a bit similar to YAML or ini files. And this format, what's nice about this is very readable, human readable, but on the other hand, it already specifies the type of variables for whatever you have here. So for example, if it's in the double quotes, it is a string. If you want it to be a string, it has to be in the double quote, this kind of stuff. If it has square brackets, it means it's an array. And again, if you want to have an array, it must have square brackets there. In this case, we declare one section, which are called tables in toml, called tools.pytest.ini options. This is a specific name which is regarded to pytest. We are going to use pytest, a pretty standard Python testing framework. And this specific section, pytest will understand and treat when we will run tests. There are three things here, as you can see. The Python path. This is really important to allow Python tests we run to allow the rest of the code to discover itself. So if I would remove something like this .source, for example, so what will happen? This Python path will actually set the Python path environment variable, and that one will be attached to the sys.pass. Whenever Python will try to, whenever the interpreter will start. And that sys.path is the main place where Python will try to search whenever trying to import something. Overall, this is quite a complicated story. I maybe will record a separate dedicated video for that. Anyway, without this, or without kind of moving some of this out, we would not be able to properly run our tests. Then the test path is the path to directory or many directories, to the folders where actually pytest will try to discover test files. So in this case, pytest is not going to look in places like the source folder, and there would be little point to do it. It will only look into the tests folder and try to find some test cases there. And then there is this adopts. Adopts itself means command line arguments. So everything in here will be added to the pytest. So whenever I will run a command like pytest, which is the basic command to do the testing, we can run it now. Actually, we can see everything looks good. There were 2 tests that passed. There is also one warning, which I'm going to address a bit later beyond this video about some deprecation functionality, but that is not really related to our tests. So what's important is then when I ran this pytest, because I had adopts equals something, it is equivalent to me grabbing this and adding it directly. So these two are equal. And this is nice because if you have something that you want to run always with your pytest, then it's super useful to add it to adopts. And that's it. That's a pretty basic, pretty small PyProject config, or like actually only pytest config at this point. It probably will grow bigger as we develop the project. Now, let's look into how the actual tests look like. In our case, we can list the tests directory with the list. Oh. Pardon my basic command line skills. So in the tests app folder, we actually have only, well, pycache, which is not interesting, and then tests app.py. This is currently the only file that I have. Let's switch actually to the Visual Studio Code. So here is this file, test_app.py. On the left, you can see the testing tab of the Visual Studio, and there were 2 unit tests discovered, 2 test cases. For now, like I've just started, and this file is going to test the app.py. Overall, kind of few words about pytest. The way how pytest discovers some tests, unit tests, and test cases is, first of all, your file has to be starting the name of the file has to start with test_. Only then pytest will consider it for checking if there are any tests inside. And then secondary, any method you want to be a test case has to start with a test_ again. The rest is irrelevant, like the name, the parameters, everything can be what you want. It has to start with test_. And so right now you can see there are 2 tests discovered. We can run them, they will succeed, which is nice. If I would remove one of these and save, you can immediately see that it's gone. It's now not a test anymore. And also if we would run now the pytest, you would see there is only one passed. And now as soon as we add it back here, there will be again two tests here, both passing. Nice. Now something else that I'm using here is fixtures, which we're going to talk in a second, but before that, let's look in the anatomy of a test. I really like to use given, when, then structure, which is a pretty popular structure for the tests, for unit tests. For my taste, this so cleanly separates the test setup in a given, running, executing the test in when, and then doing the assertions, finalizing validating the test results in then. I really like it. I also like to add these comments here to cleanly separate three sections. And it helps a lot even if I want to read just one section to understand, hey, what's going on in this test or what's the setup for this test. I really love it. If I have a test where there is no special setup to do, I still write given. So I write it like this, given when, to indicate that I haven't forgotten, I haven't missed the given part. It's just that for this test, it's not needed. And it still reads really well, given when, blah, blah, blah. I think it's still quite fluent, quite intuitive. So that's the overall test setup. We are using basic asserts for most of stuff. This is built into Python, which is nice. We want, in this file, we want to test app.py. What is app.py? Well, that's actually our main application, the ASGI app. This is the thing which is given later to our web server to do the routing and execute the logic. And so testing this application means testing all those different routes that exist in it. For now, there's only two. You can imagine there will be way more in future. For now, all of these are in the single file because there is for now only one resource, and you can see only two routes, like one resource recipe and only two routes dedicated to that recipe. There later will be a post and delete routes to actually create, change, and delete. But as this grows and as there are more and more different resources that are routed here, I probably will separate the test file from test_app to specific test_recipe resource and test_ some other resource. I will separate them into separate chunks because I don't want a huge blob of, like 1,000 lines of tests. That's pretty intimidating to my taste. For now, there are only two. And of course, if you want to test those routing, we want to have some simulation, some mock to send requests, get response, and check those responses. The way it's accomplished in Falcon is by using falcon.testing.testClient. We can give a real application to this test client. So the similar way we would give an application to the web engine, to the web server, we can give one to this test client, and it will return a nice mock. So later you can see here, I'm using this mock called client here to simulate get, and you can see here I'm simulating a get with some specific ID, for example, to test a parameterized URL. You can also imagine here simulate post, simulate delete, and all the rest. This is really nice, looks pretty clean and neat to me, almost zero setup to have all of this working. Of course, you can wonder, if you haven't worked with pytest before, hey, how the heck this client is gotten here, what magic brought it? And this is where pytest fixtures come in. So in testing overall, fixtures are typically methods which bring you some stable data, some immutable data, typically used, well, not immutable, some constant data, which is typically used for test setup, testing data setup, this kind of stuff. In this case, this is a perfect example. For any method that we are going to use here, we're going to test some URL, some route. And so we will always need a client to call simulate get or simulate something else on it. The way how pytest does it is, if you declared a new function and you add this decorator pytest fixture, pytest will understand, and when later pytest will find any real test case, a function starting with a test underscore, if a name of the argument to the test case matches exactly a name of a fixture, that fixture will be used. It's really cool. Fixtures themselves could have some other fixtures as an input. So for example, I could say that client needs an ID, and I could declare def ID, a new function, for now saying pass. And if I would say that is pytest.fixture, yeah, of course it has to be like this. So now when finding this fixture and seeing that there is a parameter called ID, pytest can check, hey, there is another fixture exactly named ID, I will put it here. So if this would be return 1, now this client would always get 1 as an ID. And you can imagine that I could the same way say, hey, here client ID, and because again ID is a fixture with this exact name, it would find and provide it here as well. This is a very nice, very clean way to provide some test data. I would say more flexible and at the same time more clean than doing just the generic on test start, on startup, on tear down kind of way, which is a different approach to set up data for testing. Definitely love pytest fixtures. And this would wrap up the main foundational thing about project setup and test setup. So kind of to sum up again, let's clear this and let's do the -L. So one important thing is to separate source files, so the code, and you can see then afterwards, like we can see ls -l source, which holds only one folder called Cookbook, and we could look into this Cookboot, and this now has a folder called adapters, and then app.py, sgi.py, these files we've looked into last time. I will talk about adapters and the way what other kind of folders will appear here a bit later in the series. For now, what's important is that the source, let's clear this again. What's important is that all the code in the source is separated from the tests. It's really nice to have all the project initiation and configuration in some file. It can be toml, it can be ini file, it can be YAML. There are typically many different options. The log config is actually something, kind of, you can Google this and check what's the structure of this. It's quite a big file. Well, and then README for GitHub is really nice, so that any person, and even myself, I keep some important stuff for myself in the README. And then for the log file, you can see that it's quite a file. There is quite some stuff. Most of this is default, but for me, for example, I've added this section called Falcon as one of the loggers and set the level of debug, and this will allow me, when I run this web server from the CLI, from the command line, this additional configuration setting will allow me to see any traceback, any real problems, so anything from the std error of my code directly in the console, and it will not be eaten by uvicorn, which otherwise would happen. So if I would have here an error, well, I don't have those, but if I would, by default, uvicorn will not show me. It will only show me something like 500 error. And that log setting allows me to see all the details directly in the command line. And then for the tests themselves, using given when done is really nice. And then using fixtures, let's actually remove this, it's not needed. Using fixtures is really clean. Oh, one additional catch that actually, something that I stumbled a bit is, we are testing here the recipe resource. And you can see that when we are calling the get, what we have is, we set here content type. So we directly say resc.contentType. This is actually a convenience option. So this content type field is a convenience way. In reality, in the real response, there will be no field. That's why here you can see that I'm not accessing directly response.contentType. Instead, I go into headers and then I query the content type header. And this is the real how the real response object would look like. While this rest.contentType is a convenience from Falcon, which would not be available, for example, here in the tests. Other than that, this is for now really straightforward. Hope it helps you. Have a nice day and see you next time.